In recent months, a seemingly ordinary object has sparked extraordinary debates. What started as a routine discovery has quickly evolved into one of the most captivating cosmic mysteries of the decade. The object, designated 3I/ATLAS, first appeared in the data gathered by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, a network of telescopes designed to identify near-Earth asteroids. But this was no ordinary asteroid or comet. Its peculiar trajectory, speed, and unexpected behaviour led some to suggest that it might not be a natural object at all. Could 3I/ATLAS be something far more remarkable, an advanced alien spacecraft passing through our solar system? The object was first detected on October 19, 2017, as it raced toward the inner part of our solar system. Initially identified as a comet-like object, it was soon apparent that 3I/ATLAS wasn't behaving like one. Unlike other objects we've observed coming from deep space, this one's speed was far too fast, and its shape appeared distinctly unusual. It was the first interstellar object ever detected in our solar system, and yet its odd behaviour raised questions that were far beyond our usual scope of study. With its unusual orbit, travelling at an astonishing speed of 315,000 km per hour, 196,000 miles per hour, it came from the direction of the Lyra constellation, an area of space that is known for its proximity to other star systems, but with no known source for such an object. While comets and asteroids typically slow down as they near the Sun, 3I/ATLAS defied that pattern, accelerating instead. This behaviour left scientists scratching their heads. Was this simply a fluke of nature, or was there something more to the object? Was it possible that we were witnessing the passage of something far more intelligent, something engineered? In the wake of this discovery, claims began circulating that 3I/ATLAS was not just a simple object from another star system, but perhaps an advanced alien spacecraft sent by a distant civilization. Some theorists have gone so far as to suggest that the object's erratic brightness fluctuations and unusual trajectory might point to artificial propulsion or even a deliberate mission, something that many felt might explain the object's behaviour. NASA, however, was quick to respond. They stated that while 3I/ATLAS was certainly an intriguing discovery, the object could still be explained by natural phenomena. Astronomers dismissed the idea of it being an alien spacecraft, attributing its unusual features to the properties of comets or interstellar dust. But even as NASA offered their own explanations, the idea of an alien spacecraft could not be completely dismissed, leaving a growing divide between skeptics and believers. What could this mean for our understanding of the universe and for humanity's search for extraterrestrial life? As new information continues to surface, scientists around the world are delving deeper into the mystery of 3I/ATLAS. Is it simply a strange visitor from another part of the galaxy, or is it evidence of something far more significant? Could this be the breakthrough that finally answers the age-old question, are we alone in the universe? And if 3I/ATLAS is not an alien spacecraft, then what is it, and what secrets does it hold? The investigation into 3I/ATLAS continues, and the answers may just be far more profound than we could ever imagine. Stay with us as we unpack the mysteries of this interstellar visitor, diving deeper into the data, the research, and the intriguing possibilities that this object might bring. When 3I/ATLAS was first observed, astronomers noticed something that set it apart from other objects in the sky. As it passed through our solar system, its brightness fluctuated in a pattern that was not only unusual, but also inconsistent with typical celestial behaviour. Comets often brighten as they approach the Sun due to the sublimation of their icy surfaces, releasing gas and dust, but the changes in 3I/ATLAS's brightness didn't quite follow this typical trend. The object seemed to dim and brighten in ways that defied the expectations of natural cometary activity, leading some scientists to suggest it might not be a comet at all. Astronomers used a wide range of telescopes to monitor 3I/ATLAS's movements and brightness, including the European Southern Observatory's Very Large Telescope and NASA's Hubble Space Telescope. The object's brightness was measured over several weeks, and it appeared to vary in intensity, but not in a manner consistent with a comet's expected behaviour. unlike other objects that undergo a gradual fade or brighten in direct relation to their proximity to the Sun, 3I/ATLAS exhibited sudden erratic fluctuations. At times, it seemed as though the object was almost turning off its luminosity, a peculiar phenomenon not typically seen in natural celestial bodies. One possible explanation offered by astronomers was that 3I/ATLAS could be a comet whose surface was covered by a thick layer of dust or ice, shielding it from the Sun's heat. When exposed, the volatile materials could evaporate and release gas, but not in the predictable manner one would expect from a normal comet. Another hypothesis was that the object was rotating rapidly, causing its reflective surface to change angles in relation to our viewpoint on Earth, resulting in the erratic brightness. But then came the radical thought. What if these fluctuations were not just random natural events, but a sign of something more controlled? Could 3I/ATLAS's changes in brightness be deliberate? Could they be an artifact of alien technology? The idea that the fluctuations could be purposeful in nature began circulating, with some theorists suggesting that the object might be an artificial probe using sophisticated technology to control its appearance. A spacecraft from an advanced civilization might have systems in place to manipulate its reflection and light emission to either camouflage itself or send signals across vast distances. NASA, as expected, stuck to a more conservative interpretation, asserting that these fluctuations were the result of natural processes such as dust clouds or the way the object reflected sunlight. Still, the idea of artificial manipulation lingered in the background of the conversation. And while it was too early to make definitive claims, it raised the important question: could this object be an attempt to communicate with us, or simply a byproduct of its natural evolution? As 3I/ATLAS continued its path through the solar system, scientists' interest in the object only intensified. What could this strange behaviour reveal? Was it a natural comet simply defying our expectations, or was something more deliberate at play? The object's brightness, as odd as it was, may have only been the beginning. Its trajectory, speed, and other strange characteristics would soon paint a more complex picture. Looking deeper into the anomaly, astronomers speculated about the nature of the object. Was it truly a comet or asteroid from another star system, or could it be something far more sophisticated? As we continue to examine the evidence, one thing is clear. 3I/ATLAS has sparked a conversation that has only just begun. It opens the door to questions that we may have to ask again and again as the mystery unfolds. What was its true purpose in crossing our solar system, and could it be a clue to something much bigger waiting to be discovered? Let's keep watching, because the story of 3I/ATLAS is only getting started. The journey of 3I/ATLAS through our solar system has been nothing short of fascinating. Unlike any object we've observed before, its trajectory, speed, and path defy typical interstellar expectations, prompting a wave of speculation about its origin and purpose. When it was first detected by the Atlas telescopes, astronomers quickly realized that 3I/ATLAS was not following the predictable orbit of a typical comet or asteroid. Instead, its path seemed entirely uncharted, an interstellar traveller with an uncanny ability to defy gravitational forces in a way that has left even the most seasoned astronomers puzzled. 3I/ATLAS was not just a random wanderer from another star system. It entered the solar system at an angle that suggested it had come from the direction of the Lyra constellation, a star field located about 27 light-years away from Earth. While this may not sound particularly distant on a cosmic scale, the object's speed and its path raised many eyebrows. Most objects in our solar system, including asteroids and comets, follow elliptical orbits that are influenced by the Sun's gravity, often slowing down or being deflected by planetary bodies. However, 3I/ATLAS had one remarkable characteristic: its velocity. Travelling at an extraordinary 315,000 kilometers per hour, about 196,000 miles per hour, 3I/ATLAS was moving much faster than any typical comet or asteroid. Its speed was not only unprecedented, but also much greater than the escape velocity of the Sun, which meant that this object was on a hyperbolic trajectory. Essentially, it was speeding through our solar system at such a pace that it would not be captured by the Sun's gravity. After passing through, 3I/ATLAS would continue on its journey out of the solar system, never to return. This high speed raised important questions. Why was 3I/ATLAS moving so fast? Most comets and asteroids, when coming from deep space, tend to follow predictable paths based on the gravitational influence of nearby stars. However, 3I/ATLAS's speed seemed to defy the usual mechanics of interstellar travel. While it was not entirely unprecedented to observe high-velocity objects entering our solar system, objects like the famous interstellar visitor Oumuamua also exhibited unusual speed. 3I/ATLAS was unique in that it did not appear to be influenced by the Sun's gravity in the same way. This anomaly opened the door to a variety of speculative explanations. One possible explanation for its unusual speed could lie in the object's physical composition. Some astronomers have suggested that it might be an ice-rich object, similar to a comet but with a denser, more compact structure. In such a case, its mass might be substantial enough to carry it through space at high velocities, while still appearing as an ordinary interstellar visitor. Others have posited that it might be composed of a combination of metals or unknown materials, making it more resistant to the gravitational forces of the Sun. But could there be something more to this? Could its speed be indicative of a deliberate propulsion system, engineered by an advanced civilization? If 3I/ATLAS were an artificial object, its high velocity could be explained by a form of propulsion that we do not yet understand, one capable of travelling vast distances at speeds that would be impossible for conventional natural bodies. Some scientists have even suggested that the object's path and velocity might be a sign of a sentient trajectory, meaning that the object was not simply drifting aimlessly, but was, in some way, actively directed through our solar system. NASA has been cautious in its statements about 3I/ATLAS, emphasizing that the object's speed and trajectory are still well within the realms of known physics. They continue to attribute the object's behavior to natural phenomena, suggesting that it is simply an interstellar visitor that has come through our cosmic neighborhood. However, this stance does little to quell the intrigue surrounding the object's unexpected velocity and trajectory. With each new piece of data, it becomes clearer that 3I/ATLAS is not just another asteroid or comet. It's something that challenges our current understanding of space travel, whether natural or artificial. As we look forward, the trajectory of 3I/ATLAS raises even more questions. What exactly is its origin? Could there be other objects like it hidden in the vast expanse of space, moving silently through the cosmos at speeds that we can barely comprehend? And if 3I/ATLAS is indeed a man-made artifact, what does it say about the possibility of intelligent civilizations existing far beyond our own solar system? While the answers remain elusive, the mystery of 3I/ATLAS continues to grow, and with it, the tantalizing possibility that we may not be the only intelligent beings in the universe. The story of 3I/ATLAS is far from over, and the questions it raises may well define the future of our exploration into the cosmos. As the data on 3I/ATLAS continue to roll in, theories emerge suggesting that the object was not simply a rogue comet or asteroid, but something far more extraordinary, a deliberate creation, possibly even an advanced alien spacecraft. These claims were fueled by the unusual features of 3I/ATLAS, its irregular brightness, unexplained trajectory, and high speed, characteristics that hinted at intelligent design. In a world where the search for extraterrestrial life has long captured human imagination, the idea of encountering an alien artifact sent waves of excitement and speculation through both the scientific community and the public. One compelling aspect of the alien spacecraft hypothesis was the peculiar nature of 3I/ATLAS's brightness fluctuations. Unlike typical comets, its brightness didn't follow the expected patterns of sublimation and gas release as it neared the Sun. Instead, the light changed abruptly, leading some theorists to suggest that these rapid fluctuations could indicate purposeful light manipulation, potentially a feature of alien technology. This possibility opened up exciting new avenues of thought. If 3I/ATLAS were an alien spacecraft, its design could be far beyond our understanding. The fluctuations in brightness might not be random, but deliberate signals, perhaps intended to communicate or gather data. Could the object be a probe, an automated visitor from a distant civilization here to study our planet or explore our galaxy. The high speed and unusual trajectory of 3I/ATLAS added weight to the engineered hypothesis. Unlike natural celestial objects which typically follow elliptical orbits, 3I/ATLAS's hyperbolic path suggested it wasn't just passing through our solar system. Its high speed would carry it beyond our solar system, never to return. Was this an intentional mission, one designed to explore without staying? Some suggested that it could be an interstellar probe, similar to the probes humanity has sent to explore the outer reaches of our solar system like Voyager. Another reason the alien spacecraft theory gained traction was the mystery surrounding the object's origin. Interstellar objects like 3I/ATLAS are incredibly rare, and the fact that it came from the direction of the Lyra constellation, home to several known stars, only added to the intrigue. What were the chances of such an object travelling through our solar system? And why was it moving in such an unusual way that didn't fit the patterns of comets or asteroids? This odd behaviour led some to wonder if it was a signal or a message from another civilization, a question that has long fascinated humanity. However, NASA and other astronomers were quick to offer counter-arguments. While 3I/ATLAS's behaviour was indeed unusual, they suggested it could still be explained by natural processes. The erratic brightness could be attributed to the object's rotation, or the reflection of sunlight off an irregularly shaped surface. They argued that 3I/ATLAS might simply be a highly unusual comet or asteroid, travelling through space for millions of years and now passing through our solar system for the first time. NASA's stance is rooted in caution, as scientists are typically hesitant to jump to conclusions without sufficient evidence. However, the possibility of 3I/ATLAS being an alien artifact raises questions that extend beyond just this object. If 3I/ATLAS were indeed a spacecraft, it would challenge everything we know about space exploration and the potential for intelligent life in the universe. Could there be more objects like it waiting to be discovered? And could humanity one day make contact with such civilizations? Or are we already unknowingly part of an interstellar network? These speculations have sparked debates within the scientific community and captivated the public's imagination. Social media and various online forums have been filled with discussions about the possible extraterrestrial origins of 3I/ATLAS. Some believe the object could be part of an effort to make contact with Earth, while others argue that it's simply the result of human projection, our tendency to see patterns and intentions in the unknown. As the mystery deepens, the question remains, could 3I/ATLAS be a sophisticated alien probe sent to our solar system? While NASA and other scientists have not endorsed this theory, speculation continues to grow, with each new revelation sparking further curiosity. With each passing day, the idea of 3I/ATLAS being an alien spacecraft seems more plausible. But as exciting as this thought is, we must remember that the boundaries of our knowledge are still being pushed. What if 3I/ATLAS isn't the first? Could other interstellar visitors be out there, waiting for us to discover them? The quest to understand 3I/ATLAS is far from over, and what we uncover next may change everything we know about the universe and our place within it. As the excitement surrounding 3I/ATLAS reached fever pitch, many turned to NASA for clarity. The Space Agency, as the leading authority on space exploration and astronomical discoveries, is often expected to provide definitive answers when it comes to unusual cosmic events. In the case of 3I/ATLAS, NASA's response was cautious, scientific, and grounded in the principles of astrophysics. While the object was undeniably intriguing, NASA's scientists quickly moved to debunk the most sensational claims about its nature, offering explanations rooted in known science rather than speculation. NASA's primary explanation for 3I/ATLAS's strange behaviour was that it is likely a natural object, a comet or asteroid from a distant star system that has been travelling through space for millions, if not billions, of years. The high speed and unusual trajectory, while atypical for objects within our solar system, could be explained by the object's hyperbolic orbit. Unlike planets and comets that are captured by the Sun's gravity, 3I/ATLAS was simply passing through, too fast to be affected by the Sun's pull. This behaviour was similar to that of other interstellar objects observed in recent years, such as the famous interstellar visitor Oumuamua. Dr. Jonathan McDowell, an astronomer at the Harvard-Smithsonian Center for Astrophysics, was among the many experts who weighed in on the situation. He noted that while 3I/ATLAS's speed and trajectory were certainly remarkable, they were not entirely outside the realm of possibility. McDowell and other scientists emphasized that the object's speed could be attributed to the typical laws of motion governing objects in space, and that there was no immediate evidence suggesting that the object was anything other than a natural interstellar visitor. NASA also sought to address the claims that 3I/ATLS's fluctuations in brightness were evidence of artificial manipulation or alien technology. Scientists pointed out that comets and other celestial bodies often exhibit erratic brightness patterns due to factors such as their rotation or the reflection of sunlight off their surfaces. In the case of 3I/ATLAS, the object's unusual shape, likely elongated or irregular, could cause it to reflect sunlight in a way that would result in fluctuations in brightness as it spun. Such changes, though startling, could be attributed to the natural behaviour of the object as it travelled through space. In response to the idea that the object might be an alien spacecraft, NASA remained firm in its position that no evidence had been found to support such a claim. The space agency reiterated that while it was always open to investigating the unknown, it needed to rely on empirical evidence and scientific analysis to draw conclusions. To date, they argued, there was no definitive proof to suggest that 3I/ATLAS was anything other than a cosmic object following the laws of physics as we understand them. However, NASA's response did not end the speculation. The public's fascination with the possibility of encountering extraterrestrial life is deeply ingrained in our collective consciousness. For many, the discovery of an interstellar object moving through our solar system was a tantalizing glimpse into the possibility of life beyond Earth. The question of whether 3I/ATLAS could be an alien probe was far from settled in the minds of the public and many scientists, even if NASA's official stance was grounded in skepticism. This divergence between NASA's scientific explanations and the more speculative theories surrounding 3I/ATLAS highlighted a deeper issue: the limitations of our understanding. While NASA's stance on the object was firmly based in known science, the sheer oddness of the object pushed the boundaries of what we thought was possible. Could something like this be more than just a natural occurrence, or were we simply projecting human desires for discovery onto an enigmatic object? The excitement and skepticism surrounding 3I/ATLAS also reveal an ongoing tension in the scientific community when it comes to the search for extraterrestrial life. The possibility that an object like 3I/ATLAS could be an alien spacecraft challenges the conventional understanding of space and forces scientists to consider the unthinkable. But it also requires an openness to new ideas that might not yet fit into our current scientific models but could revolutionize our understanding of the universe. In a broader sense, NASA's response to 3I/ATLAS underscores the importance of maintaining a rigorous scientific approach to exploring the cosmos. While the allure of extraterrestrial discovery is undeniably strong, it is through careful observation, analysis, and inquiry that we can arrive at conclusions that truly expand our understanding of the universe. If 3I/ATLAS proves to be a natural object, the scientific community will have learned something profound about the way objects move through space. If, on the other hand, further investigation reveals that the object is indeed an alien artifact, then humanity will face questions far greater than the ones posed by 3I/ATLAS alone. For now, NASA's official response leaves the mystery of 3I/ATLAS unresolved. The object remains an enigma, its true nature still shrouded in the depths of space. As we await further data from ongoing observations, the possibility of an extraordinary discovery remains tantalizingly within reach. Whatever the outcome, 3I/ATLAS has undoubtedly opened up a new chapter in the search for knowledge, one that will inspire curiosity and wonder for years to come. Before 3I/ATLAS, the idea of interstellar objects visiting our solar system was more a concept for theoretical astronomy than a tangible reality. Yet 3I/ATLAS has firmly established that our solar system is not a closed-off system, isolated from the vast expanse of space. The arrival of interstellar objects, once thought to be extraordinarily rare, now challenges how we think about the cosmos and our place within it. Interstellar objects, like 3I/ATLAS, are cosmic visitors that travel through space at high velocities, originating from other star systems. These objects offer a unique opportunity to study materials and conditions from beyond our solar system, giving us a glimpse into the wider universe. Although rare, they remain anomalies, at least for now. Interstellar objects are defined as any object that originates outside the solar system and crosses into our stellar neighbourhood. These objects typically come from other stars or star systems in the Milky Way galaxy. What sets objects like 3I/ATLAS apart from others in our solar system is their trajectory and speed. While objects like comets and asteroids are bound by the Sun's gravitational pull, interstellar objects travel on paths that are not influenced by the Sun's gravity. This means their velocity and trajectory are unpredictable by the same rules that govern solar system orbits. 3I/ATLAS, for example, entered our solar system at an unusually high speed, so high that it could never be captured by the Sun's gravity. It would continue its journey beyond our solar system, never to return. Its unorthodox path made it the first confirmed interstellar object observed passing through our solar system. Interstellar objects provide us with a rare opportunity to study materials otherwise unreachable. Scientists have speculated about the compositions of objects from other star systems, but 3I/ATLAS offers a rare chance to actually study one. Astronomers can analyse its speed, shape, and other characteristics using powerful telescopes like the Hubble Space Telescope and the European Southern Observatory. What we learn could provide valuable insights into the chemistry and materials of other star systems and refine our search for exoplanets or extraterrestrial life. The exact origins of 3I/ATLAS remain unclear. While it was first detected coming from the direction of the Lyra constellation, astronomers have been unable to pinpoint a specific star system from which it originated. This lack of definitive origin raises questions about how such objects form. Could they be remnants of a distant star's planet-forming disk, or ejected from their parent star system due to a gravitational interaction? Another important question is how common these objects are. If 3I/ATLAS is the first confirmed interstellar object observed, how many others might be passing through our solar system unnoticed? Some astronomers believe 3I/ATLAS may just be the beginning, and that improvements in telescope technology will allow us to detect more such visitors. This raises an intriguing possibility. Could the universe be filled with objects silently travelling through the galaxy, passing in and out of star systems like cosmic wanderers? Scientists are also exploring whether interstellar objects like 3I/ATLAS could offer clues about the origins of life. Could they contain organic molecules, like those found in comets or asteroids, that might help explain how life began on Earth? If 3I/ATLAS contains material from the early stages of star system formation, it could offer insights into the building blocks of life and the conditions necessary for life to exist elsewhere in the universe. NASA's interest in 3I/ATLAS and future interstellar objects goes beyond understanding their physical properties. The discovery of these objects prompts a broader question: what is our place in the galaxy, and how do we relate to the wider universe? The ability to track and study objects from other star systems suggests we may be closer to understanding how our solar system fits into the cosmic landscape. The presence of 3I/ATLAS raises the stakes in the search for extraterrestrial life and questions the nature of intelligent civilizations. While some believe interstellar objects could be precursors to something greater, such as evidence of extraterrestrial probes, others argue they are simply natural phenomena. Whatever the case, studying interstellar objects like 3I/ATLAS will deepen our understanding of the universe and challenge our preconceived notions about space and life beyond Earth. As we continue to explore interstellar objects, new questions will inevitably arise, especially as we gather more data on objects that enter our solar system. What is clear is that 3I/ATLAS has opened a new chapter in space exploration, one that offers insight into the universe's vastness and its many hidden mysteries. The story of interstellar objects is just beginning, and 3I/ATLAS may be the first of many to cross our path, As interest in 3I/ATLAS escalates, one critical question remains. What evidence supports or refutes the theories surrounding this object? The extraordinary claims made about 3I/ATLAS, especially the idea that it could be an alien spacecraft, demand a thorough examination of the available physical evidence. While the object's bizarre features have captured many imaginations, it is essential to scrutinize the data carefully before jumping to conclusions. So far, most of the evidence points toward 3I/ATLAS being a natural object, likely an asteroid or comet, but its peculiarities have made it intriguing. Let's first examine its physical characteristics, which have been captured through powerful telescopes like the Hubble Space Telescope and ground-based observatories. These observations have provided critical insights into the object's shape, composition, and behavior. One of the most striking features was its shape. Unlike most comets, which are typically spherical or roughly round, 3I/ATLAS appeared elongated. This irregular shape has led scientists to hypothesize that the object may be tumbling through space, spinning on its axis. The rapid rotation could explain some of the erratic brightness fluctuations, as the object's reflective surface might change angle relative to Earth, causing it to alternately brighten and dim. Additionally, measurements of 3I/ATLAS's size suggest that it is relatively small, likely no larger than a few hundred meters in diameter. This is consistent with the size of many small asteroids and comets, which often travel through space without causing significant impact. However, its high velocity, estimated to be around 315,000 kilometers per hour, indicates that it is moving through our solar system much faster than typical asteroids or comets. This velocity could be explained by its interstellar origin, allowing it to travel across vast distances without being slowed by the sun's gravity. Another key piece of evidence supporting the idea of 3I/ATLAS as a natural object is its composition. Astronomers have attempted to analyze its chemical makeup based on how it reflects sunlight. While the data is still limited, the object appears to have a metallic or rocky composition, consistent with asteroids and small celestial bodies. The reflectivity suggests it's made of materials commonly found in interstellar space, such as silicates or carbon-based compounds, which are typical of comets and asteroids. Beyond its physical properties, the behavior of 3I/ATLAS has raised questions about its origin. Unlike comets, which typically form a visible tail when they pass near the Sun, 3I/ATLAS did not exhibit this characteristic. This absence is unusual but not necessarily unique. The object could be a dry, rocky asteroid rather than an icy comet, or it may have already shed its volatile components before passing near the Sun. Despite these natural explanations, the possibility remains that 3I/ATLAS could be something more extraordinary. While its shape, speed, and brightness fluctuations can largely be explained by natural phenomena, the idea that it might be an artificial object, like a probe sent by an advanced civilization, remains open. Its arrival was unprecedented. Interstellar objects are exceedingly rare, and 3I/ATLAS's behavior does not entirely conform to typical space debris. Could this anomaly indicate something beyond our current understanding? NASA's stance remains cautious, stating that while the object's behavior is intriguing, there is no direct evidence to suggest that it is anything other than a natural object from a distant star system. The space agency has emphasized that science must be grounded in data and observable phenomena, not speculation. They have continued to collect data on 3I/ATLAS, and more research is needed before any definitive conclusions can be drawn. However, the absence of direct evidence doesn't completely rule out the possibility of 3I/ATLAS being an alien artifact. The data, while pointing toward a natural object, still leaves some mysteries unsolved. Its speed, trajectory, and the strange way it interacted with sunlight continue to pose questions that demand further investigation. Could future missions or new telescopes provide evidence that changes our understanding of 3I/ATLAS? Perhaps, but for now, scientists are left with more questions than answers. One of the crucial next steps for astronomers is to continue monitoring 3I/ATLAS as it exits our solar system. As it moves further away, scientists will lose the ability to observe it with the same level of detail. However, the information gathered so far will help shape future observations of other interstellar objects that might pass through our solar system. If 3I/ATLAS is indeed a natural object, it could serve as a valuable reference for understanding similar visitors from distant star systems. The evidence gathered so far points toward a natural origin for 3I/ATLAS, but the mystery surrounding its behaviour ensures that it will remain a subject of fascination and study. Whether it's a simple cosmic wanderer or something more complex, 3I/ATLAS continues to spark scientific inquiry, challenging our understanding of space and our place in the universe. As we move forward, the investigation of interstellar objects like 3I/ATLAS will undoubtedly continue. What we learn from this object will likely shape how we approach similar phenomena in the future. Until then, the true nature of 3I/ATLAS remains elusive, but the quest for answers is far from over. The arrival of 3I/ATLAS has not been an isolated event in astronomical observation. Its discovery has drawn comparisons to a previous interstellar visitor, Oumuamua. Like 3I/ATLAS, Oumuamua's unexpected behaviour and trajectory sparked debates among scientists, with some suggesting that it might be an artificial object, perhaps even an alien probe. As the first known interstellar object to pass through our solar system, Oumuamua set a precedent for how such objects are viewed, and its enigmatic features laid the foundation for much of the speculation surrounding 3I/ATLAS. Oumuamua, discovered in October 2017, was also an object unlike any other observed in our solar system. It was fast, travelling at speeds of up to 315,000 km per hour, and its trajectory didn't align with the Sun's gravitational forces. The object appeared elongated, unlike the spherical comets and asteroids typically observed. Its rapid rotation and sudden acceleration as it moved away from the Sun prompted some astronomers to speculate that it might be a probe or artifact from an advanced extraterrestrial civilization. One of the most intriguing aspects of Oumuamua was its unexpected acceleration. After passing the Sun, Oumuamua's speed increased, which is not typical for natural objects like comets. Comets usually accelerate as they approach the Sun due to the sublimation of ice and the release of gas. However, Oumuamua showed no visible signs of this process, leading scientists to propose that its acceleration could be due to outgassing or even a solar sail, a form of propulsion that could be used by advanced civilizations. The mystery of Oumuamua became a lightning rod for debates. While most scientists dismissed the idea of it being an alien spacecraft, the possibility lingered due to its peculiar behaviour and the lack of a clear explanation. NASA suggested that Oumuamua's acceleration could be explained by the pressure exerted on it by sunlight, an effect known as the Yarkovsky effect, though this theory remains speculative. Others have argued that it could have been a fragment of a larger interstellar body. The similarities between 3I/ATLAS and Oumuamua are clear. Both objects are interstellar in origin, and both display unusual behaviour. Both were first detected when already passing through our solar system, and both followed hyperbolic trajectories, moving too fast to be captured by the Sun's gravity. These similarities have led some to draw direct comparisons, suggesting that they may be part of a previously unrecognised class of cosmic wanderers. However, there are key differences between 3I/ATLAS and Oumuamua. While Oumuamua's shape and acceleration sparked much debate, 3I/ATLAS appears more similar to typical comets or asteroids in terms of composition. Its irregular brightness fluctuations and shape are unusual, but not as extreme as Oumuamua's features. Additionally, 3I/ATLAS has been travelling through the solar system at a much higher speed, making its journey even more extraordinary. Still, the questions raised by both objects about their origins, purposes, and the possibility of alien involvement remain remarkably similar. The comparison underscores the growing realization that our solar system is not as isolated as once believed. With the discovery of these interstellar objects, we must face the possibility that many more could pass through unnoticed. Just as 3I/ATLAS raised questions about alien technology, Oumuamua's mysterious behaviour prompted a rethinking of how we perceive interstellar objects. Could these objects be signals from other civilizations, or are they simply cosmic debris in motion? What is clear is that the scientific community is increasingly open to the idea that interstellar objects like 3I/ATLAS and Oumuamua may not be random visitors, but part of a larger phenomenon that could reshape our understanding of the universe. As more interstellar objects are discovered and telescopes improve, scientists will have more opportunities to study these cosmic wanderers in greater detail. The implications could be profound, not only for our understanding of space but also for the search for extraterrestrial life. The question remains, are we witnessing natural objects passing through star systems, or is there something far more significant? As the mysteries of 3I/TLAS and Oumuamua continue to unfold, the line between natural and artificial becomes increasingly difficult to draw. These objects challenge our current understanding of the cosmos and force us to consider the possibility that we may not be alone in the universe. The comparison between 3I/ATLAS and Oumuamua is just the beginning. With each new interstellar visitor, we will be forced to reassess our place in the galaxy. Could these objects be part of a larger effort by extraterrestrial civilizations to communicate with us? Or are they simply the natural byproducts of the cosmos, drifting through space? Only time and continued observation will tell. The speed at which 3I/ATLAS is travelling has become one of the most intriguing aspects of its passage through the solar system. With a velocity of 315,000 km per hour, around 196,000 miles per hour, 3I/ATLAS is moving far faster than typical objects found in our solar system. This rapid pace raises the question, why is 3I/ATLAS moving so fast, and could its velocity be a sign of something extraordinary? Its high speed sets it apart from both typical asteroids and comets, which generally travel at slower speeds due to the gravitational influence of the Sun. The high velocity of 3I/ATLAS has puzzled scientists because, in most cases, the Sun's gravity slows down objects that pass through the solar system. Comets, for example, lose velocity as they approach the Sun, and most asteroids follow predictable orbits influenced by the Sun's gravity. However, 3I/ATLAS was different. Instead of slowing down, it actually maintained or even increased its speed. The object's velocity was so high that it was not captured by the Sun's gravity, but instead followed a hyperbolic trajectory, leaving the solar system without returning. This behaviour raised several possibilities. One explanation could be that 3I/ATLAS is a dense metallic object, which would allow it to maintain its velocity over vast distances. A denser object would be less susceptible to the gravitational forces that typically affect comets and asteroids. However, its speed remains far greater than what would be expected from a natural object travelling through space. While its composition may contribute to its speed, the extraordinary velocity suggests something else might be at play. Some have speculated that 3I/ATLAS might not be a natural object but a spacecraft, perhaps sent by an advanced alien civilization. The idea of an alien spacecraft travelling at such high speeds is speculative, but it raises an interesting question. Could we be witnessing the passage of a highly advanced probe designed to move quickly through space in search of new star systems or intelligent life? If 3I/ATLAS were an artificial object, its velocity might be the result of an advanced propulsion system capable of achieving speeds far beyond anything possible with human technology. Yet, while the notion of alien technology is tempting, there are more plausible natural explanations for 3I/ATLAS's high velocity. One possibility is that it's simply the result of the object's interstellar origin. Objects from other star systems, especially those travelling at high velocities, often follow hyperbolic orbits due to gravitational influences. In this case, 3I/ATLAS could be just another cosmic wanderer, speeding through our solar system as part of its long journey through space. Its trajectory and speed might simply reflect the natural dynamics of interstellar travel. Another hypothesis involves propulsion. The object's speed could result from a gravitational slingshot, a maneuver used by spacecraft to increase their velocity by using the gravity of a planet or star. Could 3I/ATLAS have undergone a similar slingshot effect, speeding up as it passed near a massive celestial body, such as a star or black hole? While this explanation seems unlikely for an object coming from outside our solar system, it remains a possible scenario that could contribute to the object's incredible speed. In the case of 3I/ATLAS, another possibility is that its trajectory was influenced by an unknown source of force, not yet fully understood. some scientists have suggested that the object's high velocity could be caused by an unknown natural force, potentially related to how interstellar objects interact with the intergalactic medium. The solar system's gravity may have had less influence on 3I/ATLAS than initially assumed, allowing it to retain its speed as it passed through. This theory would imply that its speed is dictated by factors beyond the Sun's influence, introducing a level of complexity to its movement that we have yet to fully grasp. Regardless of the explanation, the high speed of 3I/ATLAS has pushed the limits of our understanding of interstellar objects. For a long time, it was assumed that objects from other star systems would be slower and more easily influenced by the Sun's gravity. Yet, 3I/ATLAS has demonstrated that our expectations must be reassessed. If we are to continue studying interstellar objects, we need to expand our understanding of the forces governing their movement and the factors contributing to their speed. 3I/ATLAS might just be the first of many such objects, each travelling through our solar system at speeds that defy expectations, offering new insights into the complex nature of interstellar space. In the end, the question remains, why is 3I/ATLAS moving so fast? Is it simply a natural object, following the forces of gravity as we understand them, or does its velocity suggest a more extraordinary explanation? As scientists continue to study 3I/ATLAS, more data may shed light on its true nature. Until then, its speed remains one of the most tantalizing aspects of this cosmic mystery. Among the most baffling aspects of 3I/ATLAS is its unusual pattern of brightness fluctuations, which has caught the attention of astronomers and sparked widespread speculation. Unlike the steady luminosity exhibited by most celestial bodies, 3I/ATLAS's brightness seemed to shift unexpectedly in a way that didn't align with the behaviour of typical comets or asteroids. These erratic changes in brightness have prompted some to wonder whether the object might not be a natural body at all, but instead something engineered, possibly an alien spacecraft. In most cases, the brightness of a comet or asteroid changes in a predictable way as it approaches the Sun. The Sun heats the object's surface, causing it to release gas and dust which can make it appear brighter. This process leads to gradual, predictable brightness changes. However, this was not the case with 3I/ATLAS. When astronomers first observed it, the object's brightness fluctuated in ways that didn't align with the behaviour of typical comets. At first, it appeared to brighten and dim in an erratic pattern, with no clear explanation based on its proximity to the Sun or its composition. Unlike most comets, 3I/ATLAS did not develop a visible coma or tail, further puzzling scientists. Even as it drew closer to the Sun, no gas cloud or dust trail appeared. Instead, its brightness fluctuated almost randomly. Astronomers attempted to understand these fluctuations by examining the object's shape and rotation. It was hypothesized that 3I/ATLAS might be rotating rapidly, causing its reflective surface to change angle relative to Earth. As the object spun, parts of its surface would be exposed to sunlight, making it appear brighter, while other parts would be in shadow, causing it to dim. This rotation could account for the irregular brightness fluctuations observed. Another explanation for the changes in brightness is related to the object's surface composition. Some scientists proposed that 3I/ATLAS could be made of a particularly reflective material, such as metal or ice, which might cause the brightness to vary depending on the angle of reflection. If parts of its surface were covered by a thin layer of dust or gas, this could create fluctuating effects as the surface was exposed to varying levels of sunlight. However, could there be another explanation, one beyond natural forces? Given the erratic and seemingly deliberate nature of the brightness fluctuations, some speculated that 3I/ATLAS might be using advanced technology to manipulate its light emissions. If it were an alien spacecraft, the fluctuations could be intentional, part of a system designed to either camouflage the object or communicate with observers in our solar system. While speculative, this possibility raises an intriguing question. Could these fluctuations be a form of signalling, an attempt to make contact with Earth or gather data? While the idea that 3I/ATLAS is deliberately manipulating its brightness is far from proven, it's worth considering. If we are indeed dealing with an alien spacecraft, the changes in brightness could indicate intelligent control, suggesting the object is far more sophisticated than a simple rock or comet. The ability to control light emissions to such an extent would imply technology far beyond what humanity has achieved. NASA and other scientists have remained cautious about such theories, pointing out that while the brightness fluctuations are unusual, they can still be explained by natural phenomena. The object's irregular shape and rapid rotation, combined with its reflective surface, could easily account for the changes in brightness. The behaviour of 3I/ATLAS, though unusual, may be entirely consistent with known astrophysical processes. The cause of the erratic brightness remains unanswered. Could it be the result of natural forces acting on a rotating object, or is there something more deliberate at play? As scientists continue to study 3I/ATLAS, they may gain a clearer understanding of the factors influencing its light fluctuations. For now, the object's unusual brightness fuels speculation, leaving us to wonder whether we're witnessing a cosmic anomaly or the first signs of intelligent life. As new data is gathered, the mystery of 3I/ATLAS's brightness is far from being solved. Whatever the cause, the fluctuations add another layer of intrigue to this extraordinary object. As we continue to study it, we may uncover more secrets about this cosmic visitor, secrets that could reveal far more about the universe and our place within it. The peculiarities of 3I/ATLAS and the public's fascination with its possible origins naturally draw comparisons to the previous interstellar visitor Oumuamua. As the first confirmed interstellar object to pass through our solar system, Oumuamua captured the imaginations of both scientists and the general public. Its strange behaviour, high velocity and unusual shape made it a subject of intense study, sparking debates about whether it was a natural object or something far more extraordinary. NASA's response to Oumuamua provides an interesting framework for understanding how the space agency deals with objects that defy traditional explanations. Oumuamua's discovery in 2017 by astronomers using the Pan-STARRS telescope in Hawaii marked a monumental event in astronomy. Its elongated, cigar-like shape was unlike anything previously observed, leading scientists to wonder what could cause such a strange appearance. The object's rapid rotation, spinning once every 7.3 hours, only added to its mysterious nature. Furthermore, Oumuamua's high velocity, travelling at a speed of 315,000 km per hour, meant it could not be captured by the Sun's gravity and would eventually exit the solar system, making it a one-time visitor. The most controversial aspect of Oumuamua's behaviour was its unexplained acceleration as it moved away from the Sun. Typically, objects like comets slow down due to the Sun's gravitational influence, but Oumuamua accelerated instead, an anomaly that traditional models couldn't easily explain. Some astronomers suggested that the acceleration was due to outgassing, when a comet releases gas as it heats up, but Oumuamua showed no visible signs of this. Others speculated that solar radiation pressure might be responsible, which could exert a force on the object's surface, causing it to accelerate. However, this theory didn't fully account for its rapid acceleration. This perplexing behaviour led to bold hypotheses. Avi Loeb, an astrophysicist at Harvard University, famously proposed that Oumuamua could be a probe sent by an extraterrestrial civilization. He suggested that its unusual acceleration might be the result of a solar sail, a technology used by advanced civilizations to travel through space using sunlight's pressure. Loeb's theory sparked intense debate, with many dismissing it as speculative. Despite this, Loeb's suggestion brought attention to the possibility that Oumuamua might not be a natural object at all. NASA's official stance on Oumuamua was more cautious. While the agency acknowledged the object's unusual features, it emphasized that there was no direct evidence to support the idea that Oumuamua was anything other than a natural interstellar object. NASA's scientists proposed that solar radiation pressure and outgassing could explain the object's behaviour, though these theories were still speculative. In a 2019 paper, NASA's Jet Propulsion Laboratory, JPL, explained that Oumuamua's acceleration could be due to the release of hydrogen ice or other volatile materials from its surface, which would create a subtle push. However, no visible signs of outgassing were detected, and this explanation remained speculative. Despite efforts to explain Oumuamua's behaviour, scientists have not definitively ruled out the possibility that it might be more than a natural object. The study of Oumuamua, alongside the arrival of 3I/A TLAS, has prompted a broader discussion about how scientists should approach objects that don't fit neatly into existing models. Both objects challenge our understanding of the universe, forcing us to consider the possibility that some objects may exist beyond the boundaries of current knowledge. While NASA follows a conservative, evidence-based approach, the public remains fascinated by the possibility of alien involvement. The investigation of interstellar objects like Oumuamua and 3I/ATLAS is still in its early stages, and much remains to be discovered. With advancements in technology and better data collection methods, we may eventually have answers to questions that have lingered since Oumuamua's discovery. For now, both objects serve as reminders that the universe is vast and filled with mysteries that may be beyond our understanding. 3I/ATLAS and Oumuamua share several striking similarities. Both came from outside our solar system, exhibited unusual behaviour, and sparked intense speculation about their origins. Despite these similarities, the scientific community remains divided. Some believe they are simply natural interstellar wanderers, while others wonder if they are something more extraordinary, challenging our understanding of space. NASA's studies of Oumuamua show how difficult it is to definitively categorize objects that defy expectations. 3I/ATLAS presents the same challenge. While some explanations are grounded in known science, others remain speculative, and the mystery deepens as more data becomes available. Whether these objects are evidence of extraterrestrial technology remains an open question, but their very existence highlights how much we have yet to learn about the universe and its possibilities. The discovery of interstellar objects like 3I/ATLAS and Oumuamua raises a fundamental question that has long captured humanity's curiosity. Are we alone in the universe? The study of these cosmic wanderers not only sheds light on the nature of objects travelling between star systems, but also fuels the search for extraterrestrial life. Could these objects be sent by advanced civilizations, or are they simply natural phenomena that remind us of the vastness and mystery of space? As astronomers continue to explore the possibility of extraterrestrial life, the data gathered from these interstellar visitors may help answer this age-old question. The search for life beyond Earth is not new. For centuries, astronomers have speculated about other civilizations in the universe. The discovery of exoplanets, planets orbiting stars outside our solar system, has brought the possibility of alien life into the realm of serious scientific inquiry. But finding definitive proof remains elusive. The study of interstellar objects like 3I/ATLAS and Oumuamua adds a new layer of intrigue to the question of whether we are truly alone. One of the most compelling aspects of 3I/ATLAS's discovery is the possibility that it could be more than just a natural object. Some scientists have proposed that it might be a probe or spacecraft sent by an advanced alien civilization, similar to how humanity has sent probes like Voyager into deep space. The erratic behaviour of 3I/ATLAS, including its rapid speed and irregular brightness, has led some to speculate that the object could be using advanced technology to communicate or explore our solar system. If true, 3I/ATLAS would represent the first tangible evidence of extraterrestrial technology, a breakthrough that could change our understanding of the cosmos. While the idea of an alien probe is captivating, it remains speculative. To date, there is no direct evidence to suggest that 3I/ATLAS is anything other than a natural object from another star system. However, the possibility that it is an artifact of intelligent design raises important questions about the potential for life elsewhere in the universe. If 3I/ATLAS is artificial, it could suggest that advanced civilizations are using probes to explore other star systems, much as we have done with our own space missions. The fact that 3I/ATLAS appears to have come from the direction of the Lyra constellation, home to several stars, adds to the mystery. Could this object have been sent from a star system far beyond our own? And what does this suggest about the technology and motivations of the civilization that sent it? The search for extraterrestrial life is closely linked to astrobiology, the study of life's potential beyond Earth. Astrobiologists examine environments on other planets, moons, and asteroids that could harbour life. While 3I/ATLAS has not shown any biological material, its interstellar origins make it a fascinating object for astrobiologists to study. If it is a natural interstellar visitor, it could provide valuable insights into the building blocks of life and the conditions that exist elsewhere in the galaxy. Could 3I/ATLAS contain organic molecules or other chemical compounds similar to those found on Earth? If so, it could provide important clues about the distribution of life-essential elements throughout the universe. The discovery of 3I/ATLAS also raises the possibility of a new era of interstellar exploration. If 3I/ATLAS or similar objects were sent by an advanced civilization, it could signify that we are on the brink of a new understanding of space travel. Just as humanity has developed space probes to explore distant planets, other civilizations may have developed technology to explore our galaxy. The idea that we could be the recipients of interstellar probes, whether natural or artificial, marks a significant milestone in the ongoing quest to understand the universe and the possibility of intelligent life beyond our planet. NASA's research into 3I/ATLAS and other interstellar objects will continue to shape the future of the search for extraterrestrial life. Studying these objects offers a unique opportunity to understand the dynamics of space travel between star systems and to examine the materials that make up interstellar bodies. In the future, astronomers will use advanced telescopes and technology to study more interstellar objects, potentially uncovering new information about the conditions necessary for life to exist elsewhere in the galaxy. In many ways, the search for extraterrestrial life is not just about finding other beings, it's about understanding our place in the cosmos. The discovery of 3I/ATLAS, regardless of its true nature, has expanded our understanding of the universe and deepened our curiosity about what lies beyond our solar system. Whether 3I/ATLAS is a natural object or an alien probe, its discovery serves as a reminder that the universe is vast, and we are only beginning to scratch the surface of the mysteries it holds. As we continue to explore the possibility of life beyond Earth, 3I/ATLAS and objects like it will play an important role in shaping our future endeavours. Whether through continued observation, space missions, or breakthroughs in technology, the search for extraterrestrial life is poised to reveal profound insights about the nature of the universe. The next step in this search may be closer than we think, and 3I/ATLAS could be key to unlocking the next chapter. The idea that 3I/ATLAS could be a piece of alien technology is a captivating hypothesis, though highly speculative. While scientists have offered plausible natural explanations for its odd behaviour, the possibility that it could be an artificial object, perhaps a probe sent by an advanced extraterrestrial civilization, continues to intrigue. This theory challenges our understanding of both space and technology, forcing us to reconsider the potential for life beyond Earth. The debate surrounding 3I/ATLAS's potential alien origins centres on its extraordinary characteristics. First, there's the object's speed. Travelling at 315,000 km per hour, 3I/ATLAS is far faster than typical objects within our solar system. This high velocity is difficult to explain through the gravitational dynamics of our solar system. While natural interstellar objects like comets and asteroids travel at high speeds, 3I/ATLAS's path appears deliberate, almost as if it is moving with purpose. Some theorists suggest that such velocity could be achievable by a spacecraft using advanced propulsion systems, potentially designed for long-distance travel across the galaxy. Could this object's rapid movement be the result of intelligent technology? The object's irregular brightness fluctuations further fuel the alien technology hypothesis. 3I/ATLAS displayed unexpected changes in luminosity, beyond what would be expected from a natural object. Could this be the result of sophisticated engineering, like light manipulation or communication? Many spacecraft use reflective surfaces or light-emitting systems to communicate with distant observers. If 3I/ATLAS were an alien probe, its fluctuations in brightness could be part of a system designed to transmit signals, either to Earth or another part of the galaxy. This idea adds weight to the theory that the object could be artificially engineered, with deliberate control over its reflectivity and brightness. However, most scientists remain cautious. While 3I/ATLAS's behaviour is unusual, it is still largely explainable by natural causes. The object could be a fragment of a much larger interstellar body, with its strange motion and fluctuating brightness resulting from its composition and rotation. NASA and other space agencies emphasize that extraordinary claims require extraordinary evidence, and while the idea of alien technology is alluring, there is no direct proof to support it. Moreover, the idea that 3I/ATLAS could be a probe raises many questions about its origin. If it were an alien spacecraft, who would have sent it, and why? Why would an advanced civilization send a single object, and why would it behave in such a cryptic way? These unanswered questions make it difficult to justify the alien technology hypothesis. The vast distances between stars would make sending a probe to a distant star system an incredible technological feat. What would be the motivation behind such a mission, especially if the probe behaves in such an indirect manner? Despite these questions, some still believe that 3I/ATLAS could be a glimpse of extraterrestrial technology. If the object were an alien probe sent on a mission of exploration or communication, it would offer an exciting perspective on the cosmos. Such a discovery would mark a monumental moment in the search for extraterrestrial intelligence, reshaping our understanding of space and our place within it. Even the discovery of a single object of alien origin would be a historic achievement, confirming that we are not alone in the universe. If 3I/ATLAS were an alien spacecraft, it would raise more questions than answers. What other technologies might be out there, waiting to be discovered? How advanced would a civilization need to be to send such a probe? What would it mean for humanity to make contact with an extraterrestrial civilization, even indirectly? These questions are central to the ongoing debate about the object's true nature, and they may define the next phase of our search for life beyond Earth. One of the most intriguing aspects of the alien technology hypothesis is the potential it has to shift our understanding of the universe. The discovery of alien technology would not only confirm the existence of intelligent life, but could open up the possibility of direct or indirect communication with an entirely different civilization. It would force us to rethink our assumptions about life and technology, forever altering our place in the cosmos. Despite the excitement surrounding the idea of 3I/ATLAS as an alien probe, science must remain grounded in empirical evidence. While the possibility of discovering extraterrestrial technology is tantalizing, we must continue to approach the evidence with skepticism and rigorous scientific inquiry. Until definitive proof is found, the idea of 3I/ATLAS being an artificial object remains speculative, and its true nature may never be fully understood. Nonetheless, the debate over whether 3I/ATLAS could be alien technology reflects a deeper truth. The search for extraterrestrial life is ongoing and evolving. Scientists are tirelessly working to answer the question of whether we are alone in the universe through the study of interstellar objects, exoplanets, and radio signals. As new discoveries are made, we are getting closer to understanding the vastness of the cosmos, and perhaps, one day, uncovering the evidence that proves we are not alone. One of the most intriguing aspects of 3I/ATLAS's passage through our solar system is its speed, which raises significant questions about how such an object could achieve and maintain such high velocity. The object's rapid movement challenges our understanding of typical space dynamics, prompting debates about whether its speed could be explained by propulsion or if it is simply the result of natural forces. While most conventional explanations point to gravitational interactions and natural velocities, the idea that 3I/ATLAS might employ some form of propulsion, whether natural or artificial, has sparked serious scientific discussions. To understand the propulsion theories surrounding 3I/ATLAS, it's important to first examine the laws governing the motion of objects through space. Objects entering our solar system from interstellar space typically follow hyperbolic orbits, travelling at such high velocities that they are not captured by the Sun's gravity. This trajectory is not unusual for interstellar objects, as they can enter and exit our solar system without being significantly affected by the Sun's pull. However, 3I/ATLAS's speed is noteworthy even among interstellar objects, surpassing the velocities of typical comets and asteroids. Several natural explanations have been offered for 3I/ATLAS's remarkable speed. One simple theory suggests that the object's hyperbolic orbit, shaped by the gravitational forces of distant stars and the interstellar medium, is a natural result of space dynamics. Interstellar objects are not bound to the Sun, so their trajectory is governed by the forces they encounter during their journey. However, This doesn't fully account for 3I/ATLAS's unusually high velocity compared to other interstellar objects, leading some scientists to consider more speculative theories. One such theory is that 3I/ATLAS might be utilizing natural propulsion, similar to the way comets accelerate as they approach the Sun due to gas and dust release from their icy surfaces. However, this theory faces challenges, as there were no visible signs of the typical cometary tail or coma observed around 3I/ATLAS. This absence of outgassing raises the possibility that the object might be an asteroid rather than a comet, or made of materials that do not readily sublimate. A more speculative theory is that 3I/ATLAS could be using solar sail propulsion, a technology theorized for use by advanced civilizations. Solar sails work by harnessing sunlight pressure on a large, reflective surface to propel an object through space. This technology has been demonstrated on Earth with experimental spacecraft like NASA's Light Sail. If 3I/ATLAS were an alien spacecraft, it could be using a solar sail to travel at high speeds across vast distances in space. The solar sail hypothesis gained traction after the discovery of Oumuamua, which displayed behavior that could be explained by solar radiation pressure. Oumuamua's acceleration and high velocity led some researchers to suggest it might be using a solar sail, much like 3I/ATLAS. While this remains speculative, it offers a potential explanation for how an interstellar object could maintain its high velocity without relying on traditional gravitational influences. However, the solar sail theory doesn't fully explain the peculiarities of 3I/ATLAS. For one, it is moving much faster than Oumuamua and shows no signs of the reflective material or structure needed for a solar sail. Additionally, 3I/ATLAS's trajectory suggests it didn't undergo a close encounter with a star or planet to gain momentum via gravitational slingshot effects. If 3I/ATLAS were propelled by a solar sail, its speed and trajectory would defy our current understanding of solar radiation's influence on objects at such great distances. Another radical hypothesis is that 3I/ATLAS could be using an advanced propulsion system far beyond anything we have discovered, such as an antimatter drive or a form of warp drive. While these ideas might seem far-fetched, they are not entirely outside the realm of possibility. As we continue exploring the frontiers of space technology, new propulsion systems may one day allow for high-speed travel across vast distances. If 3I/ATLAS is utilizing such advanced technology, it could explain its extraordinary speed and trajectory, though this remains purely speculative. While propulsion theories are fascinating, they are still highly speculative. The most widely accepted explanation for the object's speed is that it is simply following the natural laws of motion for interstellar objects. Its hyperbolic trajectory is consistent with what we would expect from a comet or asteroid passing through the solar system at high velocity. The idea that 3I/ATLAS is using advanced propulsion remains unproven, but it serves as a reminder of how this object challenges our understanding of space dynamics and the technologies that might be used by advanced civilizations. The possibility of alien technology forces us to reconsider what is possible in space exploration. Could 3I/ATLAS be a glimpse into a much larger and more complex reality? Or is it just another interstellar visitor following the natural paths of the cosmos? For now, the exact nature of 3I/ATLAS's propulsion remains uncertain, but as we continue to explore space and develop new technologies, we may one day find the answers to these questions. The mystery surrounding 3I/ATLAS continues to provoke curiosity, particularly regarding its possible origins. Could it be the first tangible evidence of an extraterrestrial civilization reaching out to us? Or is it simply a rare natural phenomenon? The idea that 3I/ATLAS might be of alien origin challenges our conventional understanding of space, technology, and the potential for life beyond Earth. As scientists scrutinize the object's unusual features, the notion of its alien origins remains a tantalizing mystery. The most compelling aspect of the alien origins theory lies in the object's strange behavior, particularly its high velocity, unusual trajectory, and erratic brightness fluctuations. These characteristics set 3I/ATLAS apart from typical objects we observe in space. Its speed, far exceeding that of normal asteroids or comets, suggests that it is not simply influenced by gravitational forces in the way we expect. Furthermore, the irregular changes in brightness, unlike those seen in typical comets, have led some to speculate that the object might be manipulating its reflection or emissions. These anomalies, combined with its interstellar origins, have sparked hypotheses that 3I/ATLAS could be an alien artifact or probe sent to explore our solar system. One of the most intriguing questions is, what would motivate an extraterrestrial civilization to send an object like 3I/ATLAS across the vast expanse of space? If it were an artificial object, it could represent a probe sent to gather data on our solar system or even to make contact with Earth. The object's peculiar brightness fluctuations could be a form of signaling, a way for an advanced civilization to communicate across interstellar distances. If this were the case, 3I/ATLAS could be the first message we've ever received from an intelligent species beyond our planet. Another possibility is that 3I/ATLAS could be a relic, an ancient piece of technology that has travelled across the galaxy for millions of years. Such a scenario would suggest that the civilization that sent the object might no longer exist, leaving the probe to drift through space as a kind of time capsule. This idea raises fascinating questions about the lifespan of advanced technology and the potential for long-lasting communication between civilizations. Perhaps 3I/ATLAS is a piece of interstellar archaeology, a remnant of a long-gone civilization that happened to pass through our solar system. Despite these intriguing possibilities, the alien origins theory remains speculative, as no direct evidence has been found to support it. While 3I/ATLAS's behaviour is certainly unusual, it is still within the realm of possibility that the object is simply a natural, albeit rare, interstellar visitor. Many scientists argue that its speed, trajectory and brightness fluctuations can be explained by known physical processes, and that extraordinary claims require extraordinary evidence. The absence of any direct signs of artificial technology or communication leaves us with more questions than answers, and the mystery of 3I/ATLAS remains far from resolved. However, the idea of alien origins raises profound implications for the future of space exploration and our understanding of life in the universe. If 3I/ATLAS were an alien probe, it would mark a turning point in our search for extraterrestrial intelligence. The discovery of an alien artifact would provide undeniable proof that intelligent life exists elsewhere in the galaxy, and would challenge everything we know about space travel, communication, and interstellar exploration. It would also prompt a re-evaluation of our place in the universe, as we would no longer be alone in our cosmic neighbourhood. The search for extraterrestrial life has driven space exploration for decades, and 3I/ATLAS has reignited this quest. While the object's true nature remains uncertain, its discovery serves as a reminder that the universe is vast and filled with mysteries. If 3I/ATLAS is indeed a probe sent by an alien civilization, it would be one of the most important discoveries in human history, proving that we are not alone in the cosmos. It would open new possibilities for communication with other intelligent beings and reshape our understanding of the universe. Even if 3I/ATLAS turns out to be a natural object, its appearance is still significant. The fact that we are now aware of objects from other star systems passing through our solar system opens up new avenues for research and exploration. It reminds us that we live in a universe filled with unknowns, and that the search for life beyond Earth is far from over. Whether 3I/ATLAS is a natural phenomenon or a piece of alien technology, its discovery has expanded our view of the cosmos and deepened our curiosity about what lies beyond our planet. As we continue to study 3I/ATLAS and other interstellar objects, we may uncover more clues that bring us closer to understanding their true nature. The mystery of 3I/ATLAS, like the search for extraterrestrial life itself, is an ongoing journey that will continue to challenge our assumptions, spark our imaginations, and push the boundaries of what we know about the universe. The mystery surrounding 3I/ATLAS continues to provoke deep curiosity, prompting a range of reactions within the scientific community. For some, the object represents a cosmic enigma that challenges our understanding of space, velocity, and even the possibility of extraterrestrial life. For others, it serves as a reminder that the universe is vast and unpredictable, with much still to be understood. The reactions from scientists, particularly in astrophysics, astronomy, and astrobiology, have ranged from cautious optimism to skepticism, reflecting the complexity of 3I/ATLAS's behaviour and its potential implications. The central debate is what 3I/ATLAS truly represents. Some scientists view it as just another example of an interstellar object, an asteroid or comet that has travelled through space for millions or even billions of years. They argue that 3I/ATLAS's high-velocity, irregular shape and fluctuating brightness can be explained by natural causes, such as being a fragment of a larger interstellar body or having materials that behave unexpectedly when exposed to sunlight. These explanations, while not fully comprehensive, remain the most widely accepted in the scientific community. NASA has maintained a cautious stance on the possibility that 3I/ATLAS is anything other than a natural object. The agency's official response emphasises that extraordinary claims require extraordinary evidence. While acknowledging the object's unusual features, NASA has cautioned against jumping to conclusions about its nature. According to NASA scientists, 3I/ATLAS's high speed and strange trajectory can be explained by its interstellar origin and the dynamics of objects moving through space. There is no immediate evidence to suggest that 3I/ATLAS is an alien spacecraft, and any such claims remain speculative. For some researchers, however, 3I/ATLAS's behaviour raises questions about the limits of our scientific models. Its high velocity, in particular, defies easy explanation. Most comets and asteroids are influenced by the Sun's gravitational pull, which slows them as they approach. Yet 3I/ATLAS is moving so fast that it is on a hyperbolic trajectory, meaning it will escape the Sun's gravitational influence entirely. This unprecedented speed has led some to consider the possibility that 3I/ATLAS is not just a random interstellar object, but something far more sophisticated. The idea that it could be an artificial probe sent by an advanced civilization cannot be entirely ruled out, though it remains an open question that requires further investigation. Beyond the immediate mystery of 3I/ATLAS, its discovery has sparked a larger conversation about the search for extraterrestrial intelligence, SETI. If 3I/ATLAS were an alien spacecraft, it would represent the first tangible evidence of an advanced extraterrestrial civilization, a breakthrough in the search for life beyond Earth. The possibility of making contact with an alien civilization has captivated scientists and the public for decades, and 3I/ATLAS offers a potential glimpse into what such contact might look like. Some SETI researchers have expressed cautious optimism about the object being a probe sent to explore our solar system, though they emphasise the need for more data before jumping to conclusions. The debate within the scientific community is not just about 3I/ATLAS, but also about how we approach the search for extraterrestrial life. Some researchers argue that it is premature to consider alien involvement without more definitive evidence. They caution that human nature often leads us to see patterns in the unknown, and that 3I/ATLAS's behaviours, while unusual, can still be explained by natural processes. The object's brightness fluctuations, for instance, could be due to its rotation or surface composition, and its high velocity could be the result of the dynamics of interstellar travel. These researchers advocate for a more cautious, evidence-based approach to studying 3I/ATLAS and other interstellar objects. On the other hand, some scientists argue that the discovery of 3I/ATLAS challenges the boundaries of what we know about space, and that we should remain open to the possibility that the object represents something more extraordinary. The fact that 3I/ATLAS is the first known interstellar object to pass through our solar system, and that it exhibits such unusual behaviour, suggests that there is still much we don't understand about the universe. These researchers believe that the object's characteristics merit further study, and that we should not dismiss the possibility of alien technology too quickly. The debate reflects a larger issue in the scientific community: the limits of human knowledge. As our understanding of space expands, we are constantly confronted with new phenomena that challenge our assumptions about the universe. 3I/ATLAS, like Oumuamua before it, forces us to reconsider what we know about interstellar objects, space travel, and the potential for life beyond Earth. Whether the object turns out to be a natural interstellar visitor or an artificial probe it has already sparked a paradigm shift in our thinking about the cosmos. As more data is collected and new observations are made, the scientific community will continue refining its understanding of 3I/ATLAS. Future missions to study interstellar objects through telescopes or spacecraft may help answer the questions that 3I/ATLAS has raised. For now, the mystery remains, and the debate within the scientific community is far from settled. Whether we are on the verge of discovering alien technology, or simply witnessing an extraordinary natural phenomenon, 3I/ATLAS has made its mark on the scientific world, reminding us that there is still so much more to learn about the universe. As 3I/ATLAS continues its journey out of our solar system, the question of how it achieved its remarkable speed remains one of the central mysteries. While scientists have offered plausible explanations for its high velocity, including gravitational forces and natural outgassing, the idea that the object might be utilizing an advanced propulsion system continues to stir the imagination. Could 3I/ATLAS's speed be the result of technology far beyond our current understanding? This theory, though speculative, raises the intriguing possibility that the object is not simply a cosmic wanderer, but a carefully engineered spacecraft sent on a mission that could be far beyond our comprehension. One of the most discussed propulsion theories centers around solar sails, a proposed form of space propulsion that harnesses sunlight to propel a spacecraft. Solar radiation can exert a continuous force on objects with large reflective surfaces, and the idea is that by deploying thin sails, a spacecraft could gradually accelerate to high speeds without using fuel. NASA's Light Sail project has demonstrated this technology on a small scale, and if 3I/ATLAS were using solar sail technology, its high speed could be explained by sunlight pressure acting on its surface as it travelled across vast distances. Unlike traditional propulsion, solar sails require no fuel, making them ideal for long-term interstellar travel. However, there are significant challenges with this theory. For one, 3I/ATLAS would need an enormous surface area to effectively utilize solar radiation pressure. Current technology cannot build solar sails capable of carrying the mass of an object the size of 3I/ATLAS, and no signs of the necessary reflective surface have been observed. Furthermore, the object's trajectory suggests that it did not undergo a close encounter with a star, which would be necessary for solar sails to operate at maximum efficiency. Another speculative theory involves the possibility of advanced as yet undiscovered methods of propulsion. One potential candidate is electromagnetic propulsion, which uses magnetic fields to propel objects through space. While this technology is still theoretical, some scientists speculate that future civilizations could generate powerful magnetic fields strong enough to drive spacecraft across vast distances. Ideas like ion drives or even warp drives continue to capture the imagination, though they remain unproven. If 3I/ATLAS were using such advanced propulsion, it would suggest technology far beyond anything humanity has ever created. The discovery of such technology would have profound implications for our understanding of space, potentially placing 3I/ATLAS at the forefront of a new era in space exploration, one that transcends the limitations of current human technology. However, the lack of concrete evidence makes it difficult to support this idea fully. We have not observed any direct signs of propulsion mechanisms in 3I/ATLAS. No emissions, no visible engines, and no detectable energy signatures that might indicate advanced technology. Until such evidence is found, the idea of 3I/ATLAS using an advanced propulsion system remains speculative. Another conventional explanation for the object's speed is the possibility of gravitational slingshot effects. This phenomenon occurs when an object passes close to a planet or star, gaining speed as it is gravitationally slung in the direction of its path. While 3I/ATLAS didn't appear to make close encounters with planets or stars, some scientists suggest it might have been influenced by gravitational interactions with objects in other star systems, or even by unseen dark matter or gravitational anomalies. This theory accounts for the object's unusual speed within known physics. The question of propulsion continues to be one of the most debated aspects of 3I/ATLAS's journey. Whether the object is simply a natural interstellar wanderer or an advanced spacecraft using cutting-edge propulsion technology will require more data to resolve. As 3I/ATLAS moves farther away from the Sun, scientists will lose the ability to observe it directly. However, the data collected so far could serve as a valuable reference for understanding future interstellar objects, and might lead to new theories about high-speed space travel. Regardless of its true nature, 3I/ATLAS has expanded our understanding of space travel and the possibilities beyond our current technological capabilities. It reminds us that the universe is vast and full of unknowns, and our journey into space is only just beginning. The study of 3I/ATLAS will continue to inspire scientific inquiry for years to come. The notion that 3I/ATLAS could be an artifact sent by an extraterrestrial civilization is one of the most provocative and exciting possibilities in the ongoing study of the object. Its behaviour, including high velocity, irregular trajectory, and erratic brightness fluctuations, suggests something beyond the ordinary. If 3I/ATLAS is indeed an alien probe or spacecraft, it would mark a monumental discovery, completely altering our understanding of life in the universe. However, this remains speculative, and scientists are grappling with the tension between the available evidence and the allure of what might lie beyond. The question at the heart of the alien origins theory is whether an object travelling at such high velocity and displaying such unusual behaviour could really be a product of extraterrestrial technology. The high speed of 3I/ATLAS is one of its most discussed features. Moving at over 315,000 km per hour, far faster than typical objects in the solar system, its trajectory suggests it is not simply passing through on a natural orbit. Some theorists speculate that its velocity could be indicative of a propulsion system, advanced solar sails, electromagnetic fields, or something else entirely. If 3I/ATLAS is using such advanced propulsion, it could be the first direct evidence of intelligent alien life-sending technology into our solar system, challenging our understanding of space travel and interstellar civilizations. However, while the alien origins theory is tantalizing, it remains speculative. No direct evidence has been found to support it. Many astronomers argue that 3I/ATLAS's peculiarities can be explained by natural phenomena that we have yet to fully understand. Some scientists propose that the object could be an asteroid or comet, pushed to high velocities by gravitational forces or the dynamics of cosmic movement. Its erratic brightness might be explained by its rotation or surface composition rather than deliberate light manipulation. While the possibility of an alien spacecraft cannot be ruled out, it remains highly speculative without more concrete evidence. Still, the possibility of extraterrestrial involvement raises important questions. If 3I/ATLAS were an alien probe, what would its purpose be? Why would it be sent in such a cryptic manner? Some scientists suggest that it could be an attempt to gather information about our solar system, much like humanity has sent probes like Voyager and Pioneer to explore distant star systems. Could 3I/ATLAS be part of an interstellar exploration program, monitoring distant solar systems, including ours? And if it is a probe, what kind of technology might it contain, and what would its creators hope to learn from Earth? The idea that 3I/ATLAS is an alien artifact also raises philosophical and existential questions. If we are encountering an alien probe, it would signify that humanity is not alone in the universe. It would prove that intelligent life has evolved beyond Earth and developed the technology to explore interstellar space. Such a discovery would profoundly alter humanity's understanding of its place in the universe, inspiring new research in astrobiology, physics, and technology. For some, it would be a momentous occasion, the first confirmed proof that we are not the only intelligent species in the galaxy. However, this discovery would also bring about a host of new questions. How would we respond to such a revelation? What steps should we take in terms of communication or engagement with a potential extraterrestrial civilization? Even if 3I/ATLAS is merely a relic from a long-gone civilization, it would invite us to reconsider the implications of intelligent life beyond Earth. How might we prepare for future encounters, and how could we interpret signals from other civilizations? Despite the excitement surrounding the possibility of alien origins, the scientific community remains divided. Some argue that we should approach the object with skepticism, noting that extraordinary claims require extraordinary evidence. Others maintain that we should remain open to all possibilities, as our understanding of the universe is still evolving. Even if 3I/ATLAS turns out to be a natural object, its existence reminds us that there are still many mysteries to uncover in the vastness of space. Ultimately, the debate over whether 3I/ATLAS is an alien artifact or a natural object will depend on future observations and studies. As scientists continue to collect data and refine their models, new clues may emerge that either support or challenge the alien theory. But for now, the object's enigmatic characteristics serve as a symbol of the unknown. The fact that we have detected such an object, travelling through our solar system from a distant star system, reminds us that there is still much to learn about the universe. Whether 3I/ATLAS is an alien spacecraft, an ancient relic, or a natural interstellar wanderer, it has sparked renewed interest in the search for extraterrestrial life. Its journey has reignited questions about intelligent civilizations, interstellar travel, and the potential for life beyond Earth. As we continue to explore the cosmos, we will undoubtedly encounter more mysteries like 3I/ATLAS, objects that challenge our understanding of space and our place in the universe. The search for answers may be long, but with each discovery we move closer to unraveling the mysteries of the cosmos. The discovery of 3I/ATLAS and the ensuing debates have sparked a range of reactions within the scientific community, highlighting the tension between excitement over its mystery and the cautious, evidence-driven approach of modern science. Astronomers, astrophysicists, and experts from various fields have weighed in, with varying opinions reflecting the broader uncertainty that comes with objects that challenge our understanding of space, physics, and interstellar travel. At the forefront of these reactions are scientists grounded in observational astronomy. Many view 3I/ATLAS as another cosmic object with unusual properties, requiring further study to fully understand. Their focus is on gathering more data to develop a better model of the object's behaviour, stressing that it's essential to refrain from jumping to conclusions. According to these scientists, the object's unusual features may be explainable by physical processes we don't yet fully understand, such as how irregularly shaped objects reflect sunlight, or how dust clouds affect a comet's appearance. NASA's official response has mirrored this cautious approach. The space agency has pointed out that the high velocity and strange trajectory of 3I/ATLAS could be explained by its interstellar origin and the natural dynamics of objects travelling between stars. Their priority remains on collecting more data and refining existing theories, emphasising that extraordinary claims, such as the possibility of it being an alien spacecraft, should be based on more evidence. On the other hand, some researchers are more open to considering unconventional explanations. These scientists are intrigued by 3I/ATLAS's unusual speed, erratic brightness, and trajectory. They argue that the object's behaviour, combined with its interstellar origins, may point to something beyond the ordinary, perhaps a sophisticated probe sent by an extraterrestrial civilization. This view is particularly influenced by comparisons to Oumuamua, another interstellar object that displayed unusual behaviour and led to similar debates about its origin. The possibility of 3I/ATLAS using advanced propulsion or light manipulation systems has led some to speculate that it could be extraterrestrial technology. For some astronomers, the idea of 3I/ATLAS as an alien artifact raises profound questions about the future of space exploration and humanity's place in the cosmos. If confirmed as a probe or artifact sent by an alien civilization, it would represent a historic breakthrough in the search for extraterrestrial life. Such a discovery would fundamentally change our understanding of space, technology, and the potential for intelligent life beyond Earth. The excitement around these ideas underscores the deep curiosity and wonder that the search for extraterrestrial life continues to inspire. However, skepticism remains prevalent. Some scientists caution that until definitive evidence is found, it's more prudent to consider natural explanations for the object's behaviour. The absence of direct signs of alien technology, such as radio signals or clear evidence of artificial propulsion, means that the claim of an alien origin remains unsubstantiated. These researchers advocate for further study of 3I/ATLAS's physical characteristics to uncover a more natural explanation. This debate highlights a broader issue. how do we respond to evidence that challenges our current understanding of the universe? The search for extraterrestrial life has long been fraught with uncertainty, and while 3I/ATLAS's discovery is exciting, it also reminds us that science must remain grounded in empirical data and skepticism. This approach ensures that we explore all potential explanations without prematurely jumping to conclusions. As scientists continue to study 3I/ATLAS, the object will serve as a focal point for future research into interstellar objects and the search for life beyond Earth. Advances in telescope technology and observational methods may provide further insights into the object's true nature. Whether 3I/ATLAS is ultimately revealed as a natural object or an artificial probe, it will continue to inspire new lines of inquiry and push the boundaries of our understanding. The reaction to 3I/ATLAS also speaks to the excitement it has generated among the public. While some skeptics caution against jumping to conclusions, the discovery of an interstellar object has sparked widespread interest in space exploration and the possibility of extraterrestrial life. The object's enigmatic characteristics have captured imaginations around the world, fueling speculation and theories about intelligent life in the universe. Ultimately, the scientific community's reaction to 3I/ATLAS highlights the complexity of studying objects that defy existing models. As new data is collected and new theories are developed, the mystery of 3I/ATLAS may eventually be resolved. But until then, the object serves as a reminder that the universe is full of surprises, and there is still much to learn about the cosmos and our place within it, as 3I/ATLAS continues its journey out of our solar system. Many mysteries surrounding the object remain unsolved. While scientists have gathered significant data, key questions about its origin, composition and purpose remain unanswered. The object has captivated not only the scientific community but also the public, reigniting interest in space exploration, extraterrestrial life, and interstellar studies. Looking ahead, the study of 3I/ATLAS will continue, though direct observation will soon diminish as it moves farther away from the Sun and Earth. Still, the data collected thus far provides valuable insights for future research on interstellar objects. By analysing its composition, trajectory and behaviour, scientists may learn more about the nature of interstellar travel and the conditions in distant star systems. One of the most important next steps in studying 3I/ATLAS is to continue monitoring it with both ground-based and space-based telescopes. Although the object is moving away, further observations may provide more insights into its speed, trajectory, and any anomalies that could indicate something beyond the ordinary. As more interstellar objects are discovered, comparisons with 3I/ATLAS could help researchers look for patterns that deepen our understanding of these cosmic visitors. In addition to ongoing observations, 3I/ATLAS may inspire new technology and methods for studying interstellar objects. Advancements in telescope technology could lead to more precise measurements and better instruments for tracking objects as they pass through our solar system. New tools like space-based observatories or specialized probes might provide an unprecedented level of detail to help resolve some of the unanswered questions. Looking further into the future, 3I/ATLAS could serve as a test case for missions that study interstellar objects in person. Sending spacecraft to explore objects passing through our solar system may seem far-fetched, but with advances in space exploration technology, such missions could eventually become possible. NASA's ongoing work on propulsion systems like ion drives and solar sails could one day make it feasible to send probes to study objects like 3I/ATLAS up close. These missions could provide valuable data on how objects from other star systems interact with our own. The excitement surrounding 3I/ATLAS has also energized the search for extraterrestrial life. While the idea of it being an alien spacecraft remains speculative, its discovery highlights the potential for finding evidence of intelligent civilizations beyond our solar system. The notion that an object might come from another star system or be an artifact of an advanced civilization raises profound questions about the nature of life in the universe. Discoveries like 3I/ATLAS remind us that the universe is vast, and the possibilities for life beyond Earth may be greater than we can currently imagine. The search for extraterrestrial intelligence, SETI, is already underway, with scientists working to detect signals from distant civilizations. If 3I/ATLAS is indeed an alien probe, it could be a precursor to future breakthroughs in SETI. The object's unexpected arrival and unusual behaviour suggest that there may be much more to learn about how civilizations in other parts of the galaxy communicate and explore space. The next steps in the search for extraterrestrial life will involve refining our tools for detecting alien signals, studying potential biosignatures on exoplanets, and continuing to look for interstellar objects that might hold clues to the existence of intelligent beings. Whether 3I/ATLAS is ultimately revealed to be a natural object or a piece of alien technology, its discovery marks a milestone in our exploration of the cosmos. It serves as a reminder that we are still in the early stages of understanding the vast universe around us, with many mysteries yet to be uncovered. The study of 3I/ATLAS has already expanded our understanding of interstellar objects and their behaviour, and future research will continue to challenge and refine our models of space dynamics. In the broader context of space exploration, 3I/ATLAS may be just one of many objects from distant star systems that will pass through our solar system. As our technology improves and our ability to detect these objects becomes more sophisticated, we are likely to encounter more interstellar visitors. Each new object provides opportunities to learn more about the cosmos and our place within it. The discovery of 3I/ATLAS has sparked a renewed interest in space exploration and the search for extraterrestrial life. It has raised questions that go beyond traditional astronomy, delving into philosophy, speculation, and wonder. As we continue to study 3I/ATLAS and other interstellar objects, we move closer to understanding the nature of space, the potential for life beyond Earth, and the mysteries that still await us in the vast expanse of the universe. As 3I/ATLAS moves further out of our solar system, the object continues to raise profound questions that extend beyond its specific characteristics. Whether it turns out to be a natural object, an alien probe, or something else entirely, 3I/ATLAS challenges our understanding of the universe and forces us to confront our place within it. This mystery has sparked widespread curiosity, reigniting discussions about space exploration, the possibility of extraterrestrial life, and the future of interstellar studies. The most important question may be how humanity will respond to the endless possibilities in the search for answers. The discovery of 3I/ATLAS is more than just a scientific anomaly. It has become a catalyst for broader conversations about the future of space exploration and the potential for contact with extraterrestrial civilizations. As we continue exploring the cosmos, the likelihood of encountering more interstellar objects like 3I/ATLAS will only increase. These discoveries will spark more excitement and speculation as we grapple with questions that remain far from answerable. 3I/ATLAS represents a shift in our approach to space exploration. It marks the first time an interstellar object has been observed passing through our solar system, offering a rare opportunity to study something from another star system up close. This discovery could reshape our models of space dynamics and interstellar travel. But beyond the data, 3I/ATLAS raises profound philosophical questions. If we are not alone in the universe, what does that mean for humanity's future? How should we prepare for the possibility of contact with more advanced civilizations? The study of 3I/ATLAS is just the beginning. As humanity pushes the boundaries of space exploration, we are bound to encounter more objects like it, and perhaps even more sophisticated ones, offering us clues about other civilizations. The discovery of such objects will not only expand our scientific knowledge, but force us to re-evaluate our place in the cosmos. For centuries, humanity has wondered whether we are alone in the universe, and 3I/ATLAS could be the first hint that the answer is no. But as we face these new possibilities, we must also acknowledge the challenges they present. The discovery of 3I/ATLAS, or any future interstellar encounter, requires a balance between scientific curiosity and caution. We must avoid rushing to conclusions or engaging in reckless speculation. While the excitement of discovery is compelling, we must remain grounded in the scientific method, relying on data and analysis rather than conjecture. At the same time, the search for extraterrestrial life and the study of objects like 3I/ATLAS will continue to fuel humanity's drive for exploration. The desire to understand the universe, answer the question of whether we're alone, and push the limits of our technology will guide future generations of scientists and explorers. Advances in space missions, telescopes, and propulsion technologies will allow us to study interstellar objects in greater detail, helping us build a clearer picture of what lies beyond our solar system. Ultimately, the most significant question raised by 3I/ATLAS is not just about the object itself, but about what it represents for humanity as a whole. The universe is vast, and as we continue to explore, we will inevitably encounter more mysteries that challenge our understanding of space, time, and life itself. These discoveries will shape the future of space exploration and define the legacy of our generation. 3. I/ATLAS is a reminder that despite our scientific and technological advancements, there is still much we do not know. Its passage through our solar system is just one chapter in the much larger story of humanity's quest to understand the cosmos. Whether 3I/ATLAS is a natural object, a relic from an alien civilization, or something else entirely, it has already changed the way we think about the universe and our ability to explore it. The search for answers will continue, and with each new discovery, we move closer to unraveling the mysteries of the cosmos. Perhaps one day, humanity will look back on 3I/ATLAS as the moment we first began to truly understand our place in the universe. Or perhaps, like many questions before it, the mystery will deepen and we will be left to wonder what lies ahead. Regardless of the answers, the journey of exploration will continue, pushing us ever forward into the unknown.